Good morning, good afternoon, good evening, everyone. We are about to start the webinar, but we'd like to wait a second for inviting people. Good morning, good afternoon, good evening, everyone. We're starting the webinar, Best Available Techniques for Industrial Emission Prevention and Control, Insights from Textiles and Paper and Pulp Manufacturing Sectors. Thank you very much for participating in the webinar today. I'm Naoko Moritani from the Environment, Health and Safety Division of the Environment Directorate of the OECD. I'd like to share Zoom instructions first. You're welcome to submit your questions at any time during the presentation using the Q&A feature in the Zoom control panel. Please specify the intended speaker and add your email address to your question, since we will basically answer questions via bilateral correspondence. And then regarding the chat function, we'll use this function to share useful information throughout the meeting. Please refrain from sending questions to the speakers via the chat. Please use the Q&A feature for that purpose. This webinar is recorded and will be made available afterwards at the specific web page. So, welcome to today's webinar again. As you may know, OECD have been working on BAT for 10 years by sharing experiences, knowledge, and best practices of the country's BAT applications to help countries prevent and manage industrial pollution. This webinar is part of the OECD's continuing work to enhance industrial emission prevention and control. The information of this webinar is derived from two reports with cross-country analysis of BAT for 6 specific industrial sectors. The activity 6 cross-country analysis of selected sectors for thermal power plants, cement, and textiles. And then activity 7 cross-country analysis of selected BREFs for iron and steel, paper and pulp, and waste incineration sectors. Among the 6 sectors, today's webinar will focus on textiles and paper and pulp manufacturing sectors. The webinar will explore how governments are using this BAT to prevent and control industrial emissions in those 2 specific areas, highlighting key environmental challenges, common emission control techniques, and opportunities for greater harmonization of BAT approaches across countries and industries. We will have a specific session for textile manufacturing first, followed by the session for paper and pulp production. Afterwards, we will have a discussion session on harmonization of BAT approaches across industries. Now, my colleague, Ms. Barak Eliasa, will briefly introduce an overview of the OECD BAT project. Barak, you have the floor.
Thank you very much, Naoko. Hello, everyone. My name is Vera Karyesha, and I'm the policy analyst for the OECD's project on best available techniques. I'd like to begin by introducing our objectives of the project. The Best Available Techniques project aims to exchange best practices among countries with mature permitting systems while supporting others in adopting BAT-based approaches. While doing so, our work also supports sustainable development goals, the target, particularly the target on 12.4, which is on the environmentally sound management of chemicals, linking environmental performance with sustainable development goals. How we do that is we have an expert group on that. We established this expert group back in 2015, and now this expert group includes over 162 members across more than 40 countries and organizations. Normally, we hold once a year face-to-face meeting and once a year online conference among our expert group members. This year, we will be hosting our 10th year anniversary, and our hosting institute will be in Seoul, Korea on 13th and 14th of November. Since 2016, the project has produced multiple key deliverables in phases of 3 years, and each phase included 3 publications. Moving to our current phase, which started this year and will last until 2027, our focus shifts to emerging and forward-looking areas for BAT implementation. Starting with our activity 10, which explores the role of BATs in hydrogen production, which is a critical pillar in decarbonizing heavy industries. This work will identify best practices that minimize emissions while supporting energy transition goals. Our other activity, namely activity 11, will turn to the recovery of secondary raw materials, which is a key strategy for advancing circular economic principles and reducing primary resource extraction. Finally, activity 12 continues the momentum with capacity building workshops, which helps countries implement findings and strengthen their technical capacities. Together, these actions ensure that BAT remains dynamic, relevant, and responsive to the global environmental technological trends. We not only publish reports, we also have online resources, such as what you're seeing on the screen. We have the website on which lists all the BREFs that are available in multiple sectors. Here you can screen based on the country and organization, the language that the BAT reference document is available, and the sector that you might be interested in looking into. With that, I'd like to pass the floor back to Nalco.
Thank you very much to Barak for briefing our project. Now I'd like to move to the session 2, activity 6 for textile manufacturing. I would like to invite speakers. So I would like to invite Barak again, and then I'd like to invite Mr. Damien De Jeter, scientific officer and the author of the European BAT reference document for the textiles industry from Joint Research Center. Also, I'd like to invite Mr. Niraj Shah, environmental engineer in the Gujarat Pollution Control Board in India. First, Barak, you have the floor to introduce the Activity 6 report.
Thank you very much, Naoko. So I'd like to begin by introducing our report, which is Activity 6. It was carried out in our phase 3, and it included a cross-country analysis of 3 globally important sectors, and among which today we will focus on the textiles manufacturing section of this report. Starting with our objectives for this report, which was to analyze globally available BAT reference documents produced to guide the sectors on ways to prevent and control pollutions for their industrial activities. So we targeted BATs and their associated emission levels for a number of sectors, as I mentioned, and their key pollutants across the world. By doing so, our ambition was and still continues to be to facilitate harmonization of BATs and their AALs across sectors and countries. How and why we selected textile sector for this report fold back to its global importance across our expert group member governments. The textile sector plays a crucial role in global manufacturing and creating employment opportunities while being a major player in exports and economic development of regions. However, we know that textiles manufacturing also brings a significant environmental burden, especially in water usage and pollution. Processes like dyeing and bleaching consume vast amounts of water and chemicals, releasing pollutants such as heavy metals and leading to being a major source of industrial wastewater pollution. As we carried out exchanges with our expert group members, we were able to determine and later agree on which pollutants were critical for this sector, as well as how to better analyze them in our cross-country analysis. Starting with, we compared 6 BAT reference documents from the EU, Flanders region of Belgium, India, Korea, the United States, and World Bank Group members. In addition, we were able to capture information from to honorary mention, China had adopted their guideline on available techniques of pollution prevention and control for textile sector back in 2021. And last year, Gujarat developed its regional BAT reference document on textiles, which we will discuss later on. Moving into how we structured this report, essentially we categorize information into 3 main bodies of the report. Starting with the section 1, which concentrated on higher BREF issues, which are essentially qualitative information on BREFs collected, such as their scope, regulatory status, and so on. In the second part, namely BAT approaches, we covered techniques and practices targeted at several aspects, such as being whether general or key environmental indicator specific or manufacturing processes. Lastly, we compiled BAT associated emission levels for the selected pollutants wherever they were available, along with their associated conditions to enable a meaningful comparison of ALs across countries. To go on more detail on what supportive information we covered on BREFs, which were provided to us from our expert group, it was the qualitative information on BREFs which provided quite important information on BREFs. This included key details about how BREFs are produced, updated, and their related regulations, and whether they included any financial aspects on the BATs that they included in their reference documents. Following the standard information on the BREFs, we delved into sector-specific aspects of each of the BREFs, such as their legal status, whether they were binding or not, their scope, as well as the environmental issues covered, whether they were single media or multimedia oriented, as well as the pollutants that they included. Looking into the technical details included in the BREFs, we looked at on whether the techniques and emission performance levels were included or not. The BREFs with both emission values and techniques included were the EU BREF, Veto BREF, which is from the Flanders region of Belgium, Korean BREF, and EHS guidelines from the World Bank. Further to this, EU, Korea, and World Bank BREFs had a multimedia approach, whereas the Veto guidance for Flanders, India, and US's effluent guidelines had single media focuses. Here you may also note that we gave an overview of how different countries approach effluent treatment in textile industry, focusing on whether or not wastewater is treated on-site, off-site, or through a combination of both systems. You may note that in the EU, effluent treatment is often managed directly on-site. This means that the treatment systems are designed and maintained right where the wastewater is generated, ensuring tighter control over emissions and easier compliance with environmental standards. Korea was noted to typically use a hybrid model, but it starts with an on-site pre-treatment. So it indicated that most textile facilities have some level of wastewater treatment at the facility itself. India required facilities to meet certain effluent standards before even using the ETPs. These are known as MINAS, namely minimum national standards, and they are legally mandated in environmental permits. Facilities often install on-site treatment units to meet these pre-discharge standards. When we looked at off-site ETPs, in Flanders, Vito-Bat study laid out standards for wastewater treatment, meaning that if a facility's internal WWTP isn't equipped to handle a specific micropollutants, those effluent streams must be separated and sent to an external treatment firms. This makes the treatment largely off-site for certain pollutant types. The US's Clean Water Act regulates both direct and indirect discharges. So the off-site treatment applies particularly to indirect discharges using public infrastructure. And when we looked at both on-site and off-site, in addition to on-site requirements, India also seemed to use combined effluent treatment plants, which is a cost-effective model for clusters of small to medium-sized manufacturers. And lastly, the World Bank's EHS guidelines offered a comprehensive look at both on-site and off-site treatment options. They don't mandate one approach over the other, but instead provide recommendations and best practices that can be adapted depending on local infrastructure and industry needs. Looking into the second section of our report, the BAT approaches, we divided the BATs that we collected into three categories, starting with general BATs, which are essentially good environmental practices regardless of the sector that it is targeted. It's essentially good environmental practices for all installations. Then we looked at key environmental indicator-specific BATs, which can be either pollutant-specific or environmental media-specific or targeted directly to the optimization of the processes. Then we looked at particular BATs specific to the subsectors. In the textile sector, this would be the processes in which are used to treat the textiles in manufacturing. Textile sector, from our understanding, has various complementary processes involved until the final product is produced from a raw material source in general. For the purposes of this study, we chose to focus on pre-treatment and dyeing processes. Pre-treatment typically includes processes like desizing, bleaching, and mercerization, which prepare the fabric for dyeing and finishing. In desizing, which removes the protective sizing and layer applied to yarns during the weaving. As I mentioned before, our analysis was conducted across 6 regions, including EU, Belgium, India, Korea, United States, and World Bank. So before we delve into the technical details, we carried out some kind of a feasibility analysis to see if these BREFs that we've collected included key comparative information on chosen processes, namely pre-treatment and its sub-processes, as well as dyeing, which helped and confirmed the diversity and availability of information across these BREFs. Following into our analysis, we noted common points raised across BREFs, starting with the acknowledgement of environmental concerns, such being high water use and toxic wastewater releases. The common BATs that we observed across the BREFs were starting with in pre-treatment stages, including desizing, bleaching, and mercerization. BATs focused on reducing chemicals use and wastewater load. For desizing, a key BAT is to recover and reuse water-soluble sizing agents, thereby reducing both waste and the need for fresh chemicals. In bleaching, the BATs noted were avoiding chlorine-based chemicals, which can produce harmful AOX. Instead, hydrogen peroxide seemed to be preferred for its lower environmental impact. For mercerization, BATs seem to involve recovering and reusing caustic soda, which reduce both chemical use and effluent volume. In the dyeing stage, main concern is chemical and metal pollution from residual dyes. So the BATs noted across the BREFs included were physical and chemical treatments, such as coagulation, flocculation, absorption, and filtration to treat the wastewater before its discharge. Also to note above, some of the BATs noted across the BREFs are seem to be material specific, meaning that they were specially designed for cotton and cellulose, allowing more targeted and effective treatment of these raw material. In this slide, we try to continue presenting the BATs adopted for certain environmental indicators, which were selected as priorities in our assessment. So looking at the three KIs, namely releases to waters, water consumption, and chemical substitution, which were selected because they represent the most critical environmental pressures in the sector itself. Starting from the releases to water, effluents from dyeing and pre-treatment contain hazardous substances like, as I mentioned earlier, heavy metals, colorants, and organic halogens. Without proper treatment, these can pollute rivers, harm aquatic ecosystems, and pose risks to public health. Secondly, we also looked at water usage. Textile production, as we know, is among the most water-intensive industrial activities, and water use is nearly in every processes, making it an essential, especially in regions where water is scarce or overexploited. Including chemical substitution meant that we looked at many chemicals, and they were in the BATs involved where many chemicals used, particularly in early process stages, are toxic, persistent, and poorly biodegradable. So switching to safer, greener alternatives helps reduce long-term environmental contamination and occupational health risks. As a final section in our report, we looked at the quantitative BATs, which are referred as BAT-associated emission or performance levels. So we tried together whenever the information was available, not only as direct discharges, but we tried to include information whenever it was available for the indirect discharges as well. And we have noted that BAT emission levels as well as performance levels varies drastically across countries as well as the BAT reference documents among the sectors itself. In our overall observation, our cross-country analysis of textile sector, starting with its scope, noted that all BREFs reviewed included core manufacturing processes analyzed in this report, such as the pre-treatment and dyeing. However, there is a notable gap when it comes to capacity thresholds. Most BREFs do not clearly define minimum plant size or throughput for which BATs applies. So this seemed to lack clarity. This lack of clarity made the applicability assessment quite a challenge. On the technical side, all BREFs described a wide range of BAT techniques for water use, chemical substitution, energy efficiency, and emission control. There were few gaps noted as well. Firstly, to start with, many BREFs either lacked or only partially include quantified emission values, such as the associated emission levels or the performance levels. So, on the second level, the details included for individual processes such as the dyeing and bleaching significantly vary between the documents. The third point noted were some BREFs allowed for flexible combinations of BATs to meet environmental objectives, which is helpful in theory but can lead to ambiguity in practice if not well specified. A major barrier to harmonization noted in our report was the lack of standard metrics for comparing the BAT performances across countries. So, for example, water consumption had been noted to measure per kilogram of textile in one of the BREFs, whereas in the other it was noted as per production batch in others, which made the difficulty in comparison. However, overall, these findings in our report highlighted not only technical inconsistencies, but also provided a broader opportunity, which could create a more harmonized, globally informed BAT framework that supports fair environmental performance in international markets. With this, I'd like to pass the floor back to Nauko.
Thank you very much to Barak for presenting the overview of the cross-country analysis in textile manufacturing in the report. Now I would like to invite Damien from the JRC, Joint Research Center of the European Commission. Damien, you have the floor and we are showing the slides.
Many thanks for giving us the possibility to introduce the European BREF for the textiles industry. So, good morning, everyone. It is the first time I talk to this group. I was involved in other OECD activities, but today I will focus on textiles industry. It's a pleasure to be here. I am one of the authors of the textiles BREF that was published 2 years ago. And you will see in the next slide the usual structure of European best available technique reference document. So the main chapters are chapter 1, containing general information on the sector. Then in chapter 2, there is a technical description of techniques used, the processes in the sector, while chapter 3 focuses on data and figures about consumption and emissions in the sector. On the chapter 4, there is a description of all techniques to consider for the determination of the best available techniques, the technical description, operational data, applicabilities. So based on chapter 4, then in chapter 5, we select the best available techniques. Chapter 5 is also in Europe a standalone document as a Commission implementing decision published at the official journal of the European Union. And this is the basis for national competent authorities to set permit conditions in the environmental permits. So on the techniques and the emission limit values or the performance levels associated to the techniques. Then in the BREF, there is a chapter on emerging technique, usually chapter 6, despite it is slightly evolving currently with the project we have in Europe with the insight and innovations to take more into account the innovation part in the BREFs. And then there is the chapter 7, concluding remarks and recommendations for future work, meaning when the BREF will be reviewed, we will look first at the contents of chapter 7 as a start. Then today, on the next slide, there is the overview of the presentation. I will focus on first some figures about the sector in Europe, and I will present some of the parameters focusing on wet processing. In the European BAT conclusions, there are more parameters covered than in the presentation today. You can see that later on, because we wanted to focus on the parameters that were included as well in the OECD report. So to start with the figures, if you go to the next slide, in Europe, the sector is represented by 360 textiles installations following under the threshold to be covered by the Industrial Emissions Directive. The threshold in Europe is 10 tons of textile materials processed per day. So if you are above the threshold, then you have to comply with the Industrial Emissions Directive and the BAT conclusions. More on the economic part, the EU textile and clothing industry, so not only the IED installations, but the whole sector represents 5% of workforce and 10% of companies in the EU. If we go to the next slide, I will be focusing on the environmental key figures. So no graphs about emissions, because it is less convenient in Europe to have ID installations above the threshold for the reporting of emissions of some parameters for emissions to air or to water. So there is less available data on emissions, focusing on the textile sector. However, for water consumption, there are values provided by the European Environmental Agency regarding the water consumption. So you see on the graph how many cubic meters are used per person every year for the textile materials, for the production of textile materials. So this includes the production that takes place in Europe and out of Europe. And you see the dark green at the bottom of the graph. So approximately 2 cubic meters. It's more or less 15% of the water consumption, corresponding to the part of the production that takes place in Europe. Then we can move to the parameters. We will start with some general considerations. First, in Europe, sometimes, depending on the installations, they emit the wastewater flow after the treatment. It's a direct release or indirect discharge through municipal wastewater treatment plants. The techniques I will present are both, for some of them, preventing techniques or abatement techniques, end-of-pipe techniques. The monitoring and the materials I will introduce today are focusing on the parameters that were included in the OECD report, but in the European BAT conclusions, there are more parameters covered, more metals, more parameters for emissions to water. And for example, pH was not a parameter considered for setting emission limits. It was considered as a contextual information parameter for us in Europe. As regards the processes, in the presentation, I will focus on wet processes, so mainly pretreatment, desizing, bleaching, mercerizing, and dyeing, while the BAT conclusions and the BREF cover also screwing, spinning, functional finishing, so more processes than the processes that will be presented today. Still on the next slide, some general considerations. The emission limit values are concentrations, so mass of emitted pollutants per volume of water in milligrams per liter. And the monitoring depends on the type of process. Either it's a continuous monitoring for continuous discharge, well, daily average values, or batch discharge, then average values over the release duration to have a homogeneous sample. As regards the abatement techniques, they are categorized either as pre-treatment on site, primary treatment, secondary treatment. Sometimes it takes place at the downstream wastewater plant, not on the installation. Then tertiary treatment, and for some of the installations, advanced treatment techniques. The next slide is the last one on general considerations. With two preventive techniques that are identified as best available techniques. The first one is about the integrated strategy for wastewater management and treatment, which sets by order of priority the use of process integrated techniques, then use of techniques to recover or reuse processed liquors, then the separate collection of wastewater streams and paste containing high loads of pollutants, and finally, the use of abatement techniques. So the order of priority is key in the BAT conclusions. The second preventive technique mentioned in the European BAT conclusions in that sector is the pretreatment of separately collected wastewater streams and paste containing high loads of pollutants that cannot be treated adequately by biological treatment. So, for example, the substance targeted are some specific substances such as organophosphorus and brominated flame retardants, PFAS, chromium, some metals, hazardous metals. And I would like to recall here that the process covered includes functional finishing, for example, and printing. So not only the wet processes. So the pretreatment here will apply whatever the process. Then, if you move to the next slide, we will start with the first parameter for emissions to water, which is AOX, with adsorption as an abatement technique identified for that pollutant, and emission limit values identified from 0.1 to 0.4 milligram per liter, only if the substance is considered relevant in the installations. So it's not all the installations that will have to comply with that, only if the presence of AOX is relevant regarding the processes that are carried out at the installation. And there is a footnote. The range may be up to 0.8 milligram per liter for dyeing polyester fibers and modacrylic fibers. The next parameter on the next slide is BOD. In Europe, BOD wasn't considered with an emission limit value. Rather, it's an indication with a value usually below 10 milligrams per liter. Because if you move to the next slide, instead of BOD, COD and TOC were considered as more used parameters. So for COD, there is a threshold from 40 to 100 milligram per liter for direct discharge only, with a possibility to have a higher end of the range up to 150 milligrams per liter. However, as COD uses toxic compounds to be determined, there is a preference. You see that in the bullet, in the middle part of the remarks in the table. So there is a preference for so either the COD material apply or the TOC applies. And TOC is the preferred option because there is no use of toxic compounds to determine it, with a range for TOC from 13 to 30 milligrams per liter, and it could be up to 50 milligrams per liter. The next slide will show you the next parameter, and we start with metals. Here it's chromium, with again some techniques, abatement techniques identified for the abatement of metals, precipitation, coagulation and flocculation, chemical reduction, filtration. So usually for emissions to water, it's a combination of techniques that are used. And for chromium, the emission limit value, the range is 0.01 to 0.1 milligram per liter. For dyeing using chromium mordant or chromium containing dyes, and the range may be higher, up to 0.3 milligrams per liter, depending on the type of fiber that are used. For indirect discharge, there is a footnote because the value may not apply if the downstream wastewater treatment plant is designed and equipped to abate metals, provided that at the downstream wastewater treatment plant, the emission the limit value that applies to the downstream wastewater treatment plants, doesn't lead to a higher level of pollution in the environment compared to a direct discharge at the textile installation. So this footnote applies to several parameters. Then again, next slide is another metal. It's copper with a range here from 0.03 to 0.4 milligram per liter. Another metal on the next slide. Again, for metals, the same abatement techniques are identified. The range for nickel is 0.01 to 0.1 milligram per liter, with a possibility to have a range of 0.2 dyes that are used, or the pigments that are used in dyeing. And on the next slide, again, it will be another metal, zinc, the last one for the presentation today, with for zinc a range from 0.04 to 0.5 milligram per liter. Again, here, only if the parameter is identified as relevant at the installation, depending on the processes that are carried out, similarly to AOX. And there is a footnote applying to zinc releases. The higher end of the range may be up to 0.8 milligram per liter when treating viscose fibers or dyeing using zinc-containing cationic dyes. So based on technical needs. With this, we can move to water consumption on the next slide. The other aspect covered in the BAT conclusions. Here, with some preventing techniques, management techniques. So for water consumption, installations have to implement a management plan, have to carry out audits regularly. Then to optimize the production. For example, optimize the scheduling, the production scheduling, the process flow. Installations also implement, use techniques to separate wastewater streams based on the type of contaminants that are in it. Considering the possibility, if possible, to reuse some water streams without treatment to reduce the water consumption. Then they have to implement changes in the process if relevant, depending on their situation. And as regard the value itself, the calculation for the specific water consumption is the total annual amount of water consumed for a specific process, including water used for washing, rinsing purposes, cleaning, minus the water reused or recycled to the same process. So in cubic meters, and it's a yearly value, divided by the total amount of textile materials treated in the process in tons per year. You will see on the next slide the table of indicative levels. They are not mandatory in the BAT conclusions published for that sector. With here, not to mention one by one, but you see that for dyeing, at the bottom of the table, batch dyeing and continuous dyeing, here the values are, for the other processes, the values are quite narrow. While for dyeing, some values, for example, fabric, it's from 10 to 150, or there is for yarn from 3 to 140, so wider ranges, because it was more difficult to have specific ranges. With this, we can move to the last point of my presentation about chemicals substitution, with again here some preventing technique, management techniques. So the implementation of chemical inventory and chemicals management system. And then in the table, some general techniques focusing on poorly biodegradable substances with the substitution of alkyl phenols and alkyl phenol ethoxylates, the substitution of poorly biodegradable phosphorus or nitrogen complexing agents, with some examples given in the description, and the substitution of mineral oil-based antifoaming agents. Then in the remaining slides, you will see some examples of substitutions that were possible substitutions identified in the bad conclusions that are specific to processes. If you move to the next slide, for example, so the list is not exhaustive because there are many techniques for substituting some chemicals that are specific to processes. So if you want an exhaustive list, I invite you to download the bad conclusions and to have a look at it. But here, for example, in the pretreatment of textiles materials other than raw wool fibers, the chlorine-free bleaching, the optimized hydrogen peroxide bleaching, we sometimes in the remarks applicability restrictions depending on the type of fibers that are used or some product specifications that are limiting the use of the techniques, but all this is mentioned in the bad conclusions. Then in the next slides, it's about dyeing, other techniques, again, to substitute some type of substances you will see. So if you can move to the next slide. Thank you. Here, it's dyeing of cellulosic materials with some examples here with the minimized use of sulfur-based reducing agents with an applicability restriction due to product specification depending on the shade that is required. The other technique is the steam fixation of reactive dyes in order to avoid the use of chemicals for that process steps. If you move to the next slide, it is still dyeing. This time it's dyeing of wool fibers with techniques for reactive dyeing and metal complex dyeing. And then on the next slide, to conclude with that technique, the dyeing of polyester fibers with two techniques that are mentioned as examples for batch dyeing and the use of environmentally friendly dye stuff carriers in batch dyeing. So with this, I conclude my presentation, and should you have any requests, you will see in the next slide that you can join us by email, you can consult the website, and of course, you can download the BREFs and the bad conclusions. It's a nice recommendation for summer reading. Thank you for the floor.
Thank you very much, Damien, for presenting EU BREF on textile industry, referring to the OECD Activity 6 report. And thank you very much for sharing the technical details, especially regarding the key environmental issues. Thank you very much. Now, I would like to invite Mr. Shah from the Gujarat Pollution Control Board in India. Mr. Shah, you have the floor.
Good afternoon, everyone. At the outset, I would like to extend my sincere thanks to the OECD Secretariat for inviting Gujarat Pollution Control Board to join this important webinar series as a co-speaker and panelist. It is our privilege to be a part of this dialogue on PET and to contribute to the international exchange of knowledge and experience. I am particularly pleased to note the inclusion of Gujarat regional BREF on the textile sector in today's discussion. This initiative reflects the collaborative efforts of regulators, industry stakeholders, and technical experts in our region, and I am glad to see it being recognized at this international platform as well. I look forward to sharing insights from our experience in Gujarat, learning from the comparative analysis across countries, and contributing to the broader goal of promoting sustainable and technically sound practice globally. Thank you once again for this opportunity. With this, I would like to share a brief overview of Gujarat BREF document for textile sector. Next. As all of you may be knowing that Gujarat has historically been a major hub for textile manufacturing and was once proudly known as the Manchester of the East. With a large number of textile industries operating in the state, environmental sustainability in this sector has always been a priority. Taking proactive steps and drawing inspiration from the European concept of BET reference documents, Gujarat Pollution Control Board took the initiative to develop a comprehensive guideline tailored for the state's textile sector in Indian perspective. I am happy to share that this guideline is the first of its kind in the country. And while developing, this kind of a brave document for the Gujarat, it has been developed through a collaborative process that has been led by Gujarat Pollution Control Board, involving the Gujarat Cleaner Production Center, who acted as an author to the brave documentation. And UBA and GIZ was helpful and was guiding us in preparation of the first of its kind of this brave document, which was new to GPCB and Gujarat and probably for the country as well, wherein the industry stakeholders, NGOs, and academia were also included. Next. So with that, we declaration of intent that was signed between Gujarat Pollution Control Board, UBA, and GIZ, which had an overall objective of promotion of the best available techniques without entailing excessive cost in various industrial sectors, so as to strengthen environmental management and pollution control in the industries. Next. The Gujarat BREF document was developed through a clear and step-by-step process to ensure both technical quality and stakeholders' acceptance. We began by identifying the textile sector as a priority due to its high resource use and the pollution levels. A guidance document was prepared to outline each stage of BREF preparation and ensure consistency. A technical working group was formed, bringing together GPCB industry, experts, NGOs, academia, and international partners like UBA and GIZ. This made the process inclusive and knowledge-driven. We collected the data through site visits, surveys, and consultations. Cleaner technologies already being adopted by the industries were then identified and evaluated for their environmental impact, feasibility, and cost effectiveness. Based on this, we derived these BETs to be included in BREF document. This draft was reviewed by draft final BREF assessment and review committee, and it was refined thereafter before finalization. And throughout the process, quality assurance was ensured through clear documentation, expert validation, and transparent decision making. This structured and collaborative approach made the Gujarat BREF both technically sound and practical for implementation. So these are the steps. The steps which are on the slide are the different steps which we included in a guidance document. That includes right from beginning of defining a TOR for the author, selection of the competent author, where Gujarat Cleaner Production Council has acted as an author, then the search for the possible competent TWG member, wherein we included right from industry, NGO, machine manufacturer, academia, GPCB officials, UBA, GIZ, consultants. So omnidirectional expertise were included into the TWG member, and TWG was strong enough to provide omnidirectional opinions in the developing the BREF document. Then the TWG was activated and a call for the suggestion was the next step. Then we did with the kickoff meeting, wherein it was to agree on the scope of the BREF, to agree on the data to be collected and its format, etc. Then the elaboration of the first formal draft. Next. Then the comments to be invited from the TWG. Then the elaboration of the second formal draft, that is optional, but we did. Then the TWG's comment, final meeting, final draft, assess and review of the draft final BREF and resolving split views, if any, and finally approval from the governing board of the GPCB. Next. Since the major textile production hubs in Gujarat are located in Ahmedabad, Surat and Jodhpur, our study for developing the BREF focused on this cluster. And we specifically studied units processing cotton and polyester fabric, as they mainly represent the dominant fabric types in the state's textile industry. This helps us ensure that the BREF reflects real ground condition and is relevant to the major production practices in Gujarat. Next. So the BREF for the textile sector, as I said, it was developed by the Gujarat for the first of its kind in the country, and it was officially launched during the prestigious Vibrant Gujarat Global Summit that was held in 2024, highlighting that the state's leadership in promoting sustainable industrial practices. Next. During the entire BREF development exercise, a total of 64 best available techniques were identified. These were already being practiced by some of the progressive industries in Gujarat in any of either of these three clusters where we studied. These bets were categorized under key areas such as general management techniques, water efficiencies, energy efficiencies, process optimization and equipment modification, chemical management, pre-treatment, dyeing and printing. By documenting these proven techniques, the BREF serves as a practical guide for industries to improve environmental performance using real achievable solution, which has been already adopted by some of the industries in this cluster. Next. So these are the 5 techniques which are included under the general management technique. And these general management techniques aim to improve the environmental and operational performance of the textile industry. They help reduce resource consumption, prevent pollution, ensure regulatory compliance, and promote cleaner, more efficient production. By adopting structured system, monitoring key processes, planning efficiently, and obtaining credible certification, textile units can enhance sustainability, reduce cost, and gain greater acceptance in both domestic and international markets. Next. In the second categorization that talks about the water efficiency, that includes the technique from 6 to 15, which aims to improve the water efficiency in textile processing. A range of bets have been identified. These include recovering steam condensate and vapor from boilers and caustic recovery system, as well as reusing water from various stages like bleaching, mercerizing, cooling, and washing. Techniques such as RO concentrate reuse, wastewater recovery in rotary washers, and the use of squeeze rollers help minimize freshwater demand. Additionally, installing automatic set-off valves and adopting real-time water monitoring ensure controlled and optimized water use. Together, these techniques significantly reduce water consumption, lower effluent loads, and support sustainable and cost-effective operations in the textile industry. Next. The third sector is the energy efficiency, which includes technique number 16 to 27. That enhances the energy efficiencies in textile manufacturing, and several best available techniques that can be implemented across the utilities and production processes. This include developing an energy efficiency plan, conducting regular energy audits, and switching to more efficient equipment like screw compressions and variable frequency drives. Techniques such as cogeneration using low pressure steam turbines help in utilizing waste heat, while power factor corrections and demand controller optimize electricity use. Heat recovery system from hot wastewater, exhaust dyeing spark, and stanter flue gas significantly reduce energy losses. Additional measures like self-cleaning heat exchangers and minimizing energy use in stanter frames and dryers further reduce operational cost and carbon emissions. Altogether, these techniques aim to lower energy consumption, improve process control, and support sustainable growth in the textile sector. Now, I would like to play a short video clip demonstrating one of these adopted bets, that is the cogeneration with a low pressure steam turbine, to give you a practical glimpse of its working. Next.
The textile industry is an energy-intensive powerhouse, driving both the economy and innovation in India. However, the high energy demands pose challenges to sustainability and cost efficiency. That's where cogeneration with low pressure steam turbines comes in. By capturing and reusing energy that would otherwise be wasted, this technology not only reduces energy consumption but also cuts costs, making it a game changer for textile industries. Experts across the textile industry believe that this technique is the way forward for energy efficient.
The turbine that we have installed is known as air pressure. Producing steam at a very high level to produce electricity. Actually, whatever pressure, whatever is our requirement, according to that, we use the turbine to be rotated with the help of a motor, and we generate electricity. So our main motive, it is basically a cost-effective and energy saving thing. Like because the steam that they are already utilizing, with the help of the steam, they are rotating the turbine, and we are generating electricity, which is almost free of cost to us. Only the cost is the industrial cost of the turbine, which the payment is also hardly 7 to 8 months, I think. So a maximum 1 year you can say. And almost that we have installed 600 kilowatt of turbine, and we are able to produce 3 to 4,000 units per day, almost in 12 hours. 3 to 4,000 units per day for 12 hours. So this is one of the very cost effective. I mean, the payment is also very fast.
Seeing its promise, the Gujarat Pollution Control Board has recognized this as a best available technique.
This approach reduces electricity consumption from the grid, leading to cost savings and environmental benefits. By integrating cogeneration system, the textile industry can enhance operational efficiency, reduce energy costs, and minimize environmental impact.
Cogeneration with low-pressure steam turbines is more than just an energy solution. By conserving energy and reducing costs, we are ensuring a more efficient and responsible path forward for the textile industry. Many more such techniques have been identified in the Gujarat Textile BREF document. Find out more about it.
Similarly, in the next section, another technique number 28 to 38 has been identified under the process optimization and equipment modification. This process optimization plays a very crucial role in enhancing efficiency, reducing resource consumption, and improving product consistency in textile manufacturing. Techniques such as mechanical dewatering and residual moisture control reduce energy demand in drying operations. Open jiggers with closed maxi jiggers and installing temperature controllers help in better heat control and reduce chemical usage. Automation across processes like in color kitchen, jet dyeing, and drum machines ensures precision and minimizes human error. Adoption of advanced methods like airflow jet dyeing, cold pad batch dyeing, and continuous dyeing further enhances productivity and reduces water and energy consumption. One of the most transformative technologies is digital printing, which eliminates the need for screens, reduces waste, and allows high design flexibility with lower environmental impact. Now, I would like to play a short video clip on digital printing to give you a real-time view of how this bit is applied in practice.
India's textile industry is a global powerhouse, known for its rich history, vibrant colors, and intricate designs. But it also has its challenges. Outdated methods like rotary and screen printing consume massive resources, impacting both the environment and costs. Enter digital printing, a revolutionary technology transforming Gujarat's textile sector, offering precision, speed, and sustainability. Digital printing is not just an innovation, it's the future of textile. Recognizing its potential, the Gujarat Pollution Control Board has identified digital printing as the best available technique.
Digital printing offers substantial environmental and operational benefits. reducing amount of time and it also energy and labor intensive. Unlike traditional methods, digital textile printing uses computer-controlled printers to spray precise droplets of dyes directly onto fabric, reducing energy consumption and minimizing waste. Digital printing provides a good solution for quicker sampling, higher print rates, and greater efficiency, flexibility, and superior design capabilities. By embracing digital textile printing, industries can meet market demand sustainably while making a positive impact on our environment.
Leading industry voices also agree. Digital printing combines efficiency with unmatched quality.
જોવા જઈએ તો ડિજિટલ પ્રિન્ટિંગમાં રોટરી પ્રિન્ટિંગમાં જે ફરક છે હવે ડિજિટલ પ્રિન્ટિંગમાં કેવું છે કે આપણે CMYK કલરનું મિશ્રણ કરીને 4 કલરના થ્રુ આપણે ગમે તે ડિઝાઇન એક વારમાં કે
Excuse me, Mr. Shar. I'm very sorry for interrupting the video, but since we won't have enough time, could you please try to wrap up your presentation? Thank you very much.
Okay. Next is, the next bunch of beds are chemical. Next. Pre-treatment, dyeing, and printing. Next. So while, this framing this BREF document, we had, currently it is a voluntary as of now, and it's not a mandatory. So, and given that a large portion of the textile sector consists of small and medium scale enterprises, their understanding and willingness to adopt bets in both essential and challenging. And recognizing this, it was important for stakeholders like GIZ and UBA to consider the Indian industrial context while developing the brief. And to ensure this relevant practical applicability, a series of industrial visits, consultations with industrial association, direct interactions, and discussion with the GPCB officials were carried out. Next. We also had one capacity building workshop with OECD in last November 2024, where the international expert from Germany, Korea, United Kingdom, and UK also attended. And it was a very experience and rich knowledge sharing experience for all of us. Next. In the 2024, in the Bharat Text Expo, which was a global event, which was organized by 11 Textile Export Promotion Council, which was supported by the Ministry of Textile. Under that also, GIZ hosted a panel discussion on BET, wherein also the BREF document of GPCB was discussed. Next. And this is how we are planning to go ahead after drawing a BREF document. This is how we want to go ahead for the implementation across the industry, for which the dialogue with UBA Industries Association is going on, and UBA is providing us all the guidance for that. Next. These are the key recommendations and bad conclusions. Next. This is a message from our member secretary, sir.
It was an excellent experience of developing BREF textile from Iraq, and with the support of CAZ and UPA, I think the journey was successfully completed and enriched our knowledge and interactions with the industries. Capacity building of the stakeholders was a big step into development of this BREF, and it helped us a lot, and it increased communication and collaborations with industry as well as industry association. That interactions also enrich knowledge of the industry and even officials of the Commission. We are thankful to CAZ and UBA for coordinating and being part into this whole journey. And I'm happy to say that
Teacher.
We want to boosted our confidence that yes, now we can also move
કેટલા લોકો હતા તમે?
for other sectors for the
ભાઈ કેટલા લોકો હતા?
and
મારે
considering the
બ્રાન્ડ
success of
અમારે કરી લેવાય ને ઓફિસમાંથી
now we have started process to have a pulp and paper. We are optimistic that we will be completing this pulp and paper sector at another.
હા હા હું ટ્રાય કરીશ નીકળવાનું.
Thank you very much.
Thank you very much, Neeraj. Thank you very much, Neeraj.
I am signing out for a while and I will be rejoining in 5 minutes. So please allow me to sign out. I will be joining from other location. Please.
Okay, but we need to go to the next session. Probably you can provide some remarks in the session 4. Thank you very much for your presenting the overview of the Gujarat VAT reference document for textile sector, together with the statement from the member secretary. I appreciate it. Moving to the session 3, paper and pulp production. I would like to invite my colleague BREF to present our OECD report first, and then I would like to invite Ms. Almut Richard, a senior expert on cross-sectoral aspects of pollution control, chemical industry, and combustion plants from German Environment Agency, UBER. First, Barak, you have the floor.
Thank you very much, Nauko. Let's move on to the second report that I would like to focus today. And moving on to our latest cross-country comparison report, which was published last year, in which we analyzed BREFs for 3 globally important sectors as well, and one of which is, as seen on the screen, paper and pulp production. Starting with our objectives for this report, which is a continuation of our previous report, and it supports as well as supplements further information on the BATs that are common, as well as the differences we have noted across the sectors, as well as various jurisdictions. As our goal for the other report, this one was also to analyze globally available BAT reference documents, produce to guide the sectors on ways to prevent and control their pollutions and in their industrial activities. So we targeted BATs as well as their ALs for a number of sectors that I mentioned and their key pollutants across the world. By doing so, our ambition, as it was and continues to be, to facilitate harmonization of BATs and their ALs across countries. How we did was that in our analysis, we conducted detailed reviews of BREF documents for iron and steel, paper and pulp, and waste incineration sectors. Following the exchanges with our expert group members, these 3 sectors were chosen for their relevance to global emissions, as well as their breadth of available data in the BREFs submitted. Such were from Korea, India, European Union, China, United States, and World Bank Group. So the insights that we've gathered among these sectors and from these BREFs helped us understand how different countries developed, structured, as well as implemented BREF documents and what we can learn from each other's approaches. Looking into the paper and pulp industry particularly, it plays a crucial role in our modern lives. We know that it's powering everything from books to packaging to office supplies. It is an essential backbone of global communication, commerce, and daily sanitation. However, this industry also comes with a heavy environmental costs. It ranks among the top water-consuming industries, using millions of gallons per day, mostly for pulping and bleaching processes. The production process also relies on harsh chemicals such as chlorine-based compounds, which contribute significantly to water contamination and air pollution. Moving into the structure of our report, we began by scoping and categorizing pulping and paper-making processes, taking the existing categorization available from the European BREF of paper and pulp production, which we will discuss further later on. So among the processes that we listed, the expert group and our secretary decided to focus on kraft pulping as well as its recovery boilers and processing of paper for recycling as a focus processes for this sector. In this table, you will be able to see all of the key pollutants and the substances typically associated with paper and pulp sector, both for their air emissions and water discharges. Once looking into this table, then we checked which BREFs from different regions, like we've listed EU, US, China, Korea, and others, covered each substance. So this helped us to understand which pollutants are commonly regulated across the board, like the nitrogen oxides, oxides of sulfur, TSS, and COD. And where there are regional differences, such as ammonia being covered in the EU or hazardous air pollutants covered only in the US. From this understanding, we compiled into understanding a consolidated overview of environmental footprint. So the environmental footprint of paper and pulp industry, based on the findings from these information I've shared, focusing on BREFs and the processes. Among the most pressing concerns is the water pollution, which is generally considered as top priority in the sector. Key waterborne pollutants that we've noted included chemical and biochemical oxygen demand, as I mentioned, COD and BOD, absorbable organic halides, AOX, and various heavy chemicals. Air emissions are also notable in paper and pulp sector, especially from the recovery boilers. And the chemicals that we've noted were nitrogen and sulfur oxides, as well as particulate matter and other hazardous compounds like dioxins. So the exact substances varied according to the regional practices and regulations among the countries when we looked at the BREFs across the globe. Once we looked at all the pollutants, the KIs, and the processes available, with the discussions in our expert group, we've decided to focus on kraft pulping's emissions from recovery boilers, dust, nitrogen oxide, and total reduced sulfur. And when we looked at the paper manufactured from recycled paper, we decided to focus on its releases to water, and the compounds that we've selected to analyze were total suspended solid, COD, AOX, total nitrogen, total phosphorus, as well as the water consumption efficiency noted across the BREFs. How we wanted to categorize the BAT approaches for this sector as well, as we did for the textile sector, we divided into 3 categories. Whether the BATs were general, essentially, which are good environmental practices irrelevant to the sector but are considered to be good for all installations. Whether these BATs were key environmental indicators specific, so it be pollution specific or environmental media specific, and whether these BATs were specific to the sector itself or the processes, such as pulping or paper making. So when we looked at the BATs for air emissions from recovery boilers, starting with nitrogen oxide being the major concern, particularly from kraft recovery boilers. So we know that there's a global consensus around the selective non-catalytic reduction, or shortly known as SNCR, which is considered to be a key BAT. However, the way SNCR implemented across the BREFs and therefore across the countries seem to vary. And for particulate matter or dust, typically the BAT included were bag filters and electrostatic precipitators, shortly ESPS, which were noted for dust from kraft recovery boilers. And lastly, when it came to total reduced sulfur emissions, the methods seem to diverge across the countries. As you can see, in China, there were notes of white clay washing, and EU and World Bank documents noted gas collection and incineration. And when we looked at US effluent guidelines, we've seen BATs for combustion control. As the main concern being water pollution, the typical BATs overlapped among pollutants, meaning that, for example, for the total suspended solids control uses standard wastewater treatment techniques such as flocculation, sedimentation, and biological treatment. When we looked at the COD reduction, which was used primarily which seemed to be emphasized particularly in China and the EU. And the techniques that we've noted included coagulation, activated sludge systems, and phenton oxidation. And when we looked at AOX, as well as total nitrogen and total phosphorus, there were similar approaches being employed across the BREFs, especially for nutrient substitution, chemical treatment, and biological processes. A major focus in all of the BREFs that we've noted was to improve water consumption efficiency. And there were several BATs that seem to be marked across the BREFs, starting with closed loop water systems, condensate reuse, as well as anaerobic biological pretreatment, which is used to reduce both water use and effluent load. Also, we've seen some diverging approaches according to the regions, starting with usage of dry peelings technology in China for water savings, then moving to bed biofilm reactors in Korea for treating high concentration wastewater. And when we looked at World Bank, which promoted advanced incineration systems and volume reduction strategies for control of water efficiency. What we noted across the BREFs when we look for the paper and pulp sector, environmental impacts significantly differed depending on the mill configuration. So we understood that many facilities are seen to be integrated, meaning that they're combining pulping, paper making, and energy generation, which leads to a complex emissions profile. So from our understanding, we noted that kraft pulping seems to be by far the most dominant chemical pulping method worldwide. Regional process preferences also seem to influence emissions. For example, as I mentioned before, ammonia seems to be a focus in the EU BREFs, while hazardous air pollutants were emphasized in the US. The BREF documents also differed in their scope and details of the pollutants coverage. They reflected local priorities, industrial practices, and environmental goals. For example, some focus were more on the energy efficiency or specific substances, which depended on local concerns. So overall, while core technologies such as the SNCR or ESPNs, as well as biological wastewater treatment were common across BREFs, regional preferences and technologies reflected local environmental priorities, regulatory frameworks, and available infrastructure. These diverse yet complementary BATs indicated a global drive towards sustainable paper and pulp production. What I'd like to also complement to my presentation is to give you an overall observations from both textiles and paper and pulp sectors and our cross-country analysis. When we looked at both sectors, I wanted to highlight that the environmental control priorities in both textiles and paper industries were both heavy water users. So when we looked in both of the sectors, we can see that there are shared challenges around the pollutants, such as the CODs and AOX, as well as key differences, with heavy metals being more prominent in textiles, whereas nutrients in paper and pulp sector. Across jurisdictions, similar BATs are being applied, including activated sludge and coagulation, with increasing attention to integrated solutions like reuse and efficiency measures. Also, across both sectors, there's a clear shift from purely end-of-pipe solutions to hybrid strategies, combining process optimization with targeted treatment methods. Finally, we see a growing focus on resource efficiency and sustainability, not just treating pollutants, but also reducing waste and conserving water across the entire production processes. As we reviewed multiple regions, we try to summarize also the BATs and the BAT-AELs. Despite the differences in geography and economical context, countries have converged on similar technical solutions for pollution controls in textiles and pulp sectors. However, regulatory implementations seem to diverge. For example, in the EU BREFs and K-BREFs, the BREF seems to be binding, whereas in others, they are considered more guidelines or only standards existing for a particular sector. The differences in institutional strength and policy history also influence the scope and the pace of BAT adoption across jurisdictions. There are also specific environmental priorities of countries, such as diversities in the raw materials available and other resources available to the countries, which influence the decisions made on the BATs selected. And finally, looking at both the challenges and the opportunities of growth for these sectors, While we did our analysis, it reveals strong technical alignment. There are still major challenges, particularly around how emissions are measured, reported, and enforced. Many jurisdictions seem to still lack some consistent method for defining and tracking BAT-ALs, making direct comparisons across these BREFs quite a challenge. However, our findings also pointed to key opportunities, starting with standardization of measurements protocols and promoting international coordination, which can help align performance expectations and raise environmental standards worldwide. With this, I'd like to thank you for your time and pass the floor back to Nauko.
Thank you very much, Berak, for your presentation. Now, I would like to invite Almut to present the key environmental issues and what in pulp in the paper industry. Almut, you have the floor.
Thank you, Naoki, for the introduction, and thank you all my previous speakers. I will try to be a little bit faster because a lot of things have already been said, also by Berak, just the conclusions. She just draw. So my name is Almut Reichert. I'm working for the German Environment Agency for more than 20 years. There I'm an expert for the pulp and paper industry, and I'm also working in this OECD working group for BAT since several years. And we are also having this bilateral cooperation with India and Gujarat, and the developing of a BREF approach in Gujarat, and also for the whole country, for the textile industry. The BREF in Gujarat was published already. I think the BREF on the national level will also be published by, I hope, by the end of this year. And there's a lot of experience with the different BREF approaches. And now I will present a little bit on the BREF pulp and paper in Europe, which was elaborated already as it was published 2015. You can go to the next slide. And yeah, it's a little bit, I can give you a short overview of this document, but I will not go into much detail. It's a 1,000 pages document. You can read it as a textbook on the pulp and paper industry in Europe. There's a lot of information, but you can read yourself, and I will try to give just some examples. Next. Yeah, what I wanted to point out, maybe it's difficult to see, is what the BAT approach in Europe tried to do is to decouple the production of industrial products from the environmental pollution that is combined with this. And here you see that between 1990 and 2008, so it's quite outdated, the production of pulp and paper was growing in Europe by about 50%. And of course, some of the consumptions, also raw materials and energy, also increased. Yeah, you need more electricity and water and raw material, but it didn't increase by 50% as the production did. And when you look at the water intake, it stayed at the same level, the blue line. And if you look at the emission, they even declined, even though the production was rising. So this is what I think is a big success of this BAT approach to be able to be more efficient, to produce more product and have less emissions with it. Next slide, please. Yeah, also the structure of the European BREF, which we could not reflect in the OECD report in so much detail, is really to distinguish between the different processes of a sector. And in the pulp and paper BREF in Europe, we have 5 sectors, and we also have BAT conclusions on the different parameters for these different products or process types. So we have the chemical pulping, kraft and sulfite pulping. We have mechanical, chemi-mechanical pulping. Then we have the process paper for recycling with and without the inking process. We have the paper making and related processes and all recovery boilers and lime kilns operated in pulp mills. That's all covered in the scope, but the structure is then divided accordingly. We have 18 BAT conclusions on aspects applicability to all pulp and paper mills, so general BAT conclusions, and we have 35 BAT conclusions for individual processes and process steps as listed above. Next slide, please. Yeah, I just give a few examples for emissions to air. You can read in the chapter 341 and 431 in the OECD report. Next. When you look at the production of kraft pulp, what we did in the European BREF is to have an input-output diagram. And the most emissions to air come from the chemical and energy recovery system of the kraft pulp mill. And that are the red circled things. And for this, you come to BAT. Also, we have BAT for all of these aspects, but this is coming now. Next slide, please. So in the kraft pulping process, you have the black liquor, which comes from the cooking process. And the recovering of the chemicals of this black liquor is the major source of emissions, because the black liquor is incinerated, also to generate steam and electricity, and to recover valuable chemicals like sodium and sulfur. It is a very big incineration installation, so it has a waste gas flow of 6,000 to 9,000 cubic meter per air dry ton. Or if you look at it in hour, you have a waste gas stream as a flow of 460,000 cubic meter per hour. And it's the major source of energy for the whole process. Yeah, the pollutions are standard air pollutants like nitrogen oxides, dust, sodium sulfide, sodium carbonate, carbon dioxide, of course, sulfur dioxide, and also those malodorous compounds like reduced sulfur compounds. Next slide, please. Yes, and in the European BAT conclusions, it's you have also techniques, and when you use these techniques, you can achieve a certain level of emissions. And yeah, here you see the different BAT RELs, which also depend on the dry substance of the black liquor. And you can also see that you always put the oxygen reference level, so you know what are the concentrations, and you also see that we have concentrations and milligram per cubic meter, but also yearly average values as kilogram per ton. Yeah, for sulfur dioxide, you see that if you have a dry substance below 75%, you are allowed a little bit higher concentrations, 5 to 15 milligram per cubic meter, and also the yearly average values are a little bit higher. For the nitrogen oxide, which is very relevant because you have parts of wood that are incinerated, but since it's a process, it's not like a boiler, you cannot really apply end-of-pipe techniques very easily. So you try to optimize the combustion conditions. You have computerized combustion control. You try to steer to do the mixing of fuel and air in a very good way. And for new plants at this time, so I guess now yeah, now the plants should mainly, all of them should have this is staged air feed systems where you can insert air and at different points in the incineration. And it also depends on what type of wood you are processing. So softwood or hardwood, and also again how much dry substance you have in your black liquor. Also particulate matters, we had a big discussion during the TWG meetings. Usually you have ESP, some also have wet scrubbers, and new or major refurbishment can achieve 10 to 25 milligram per norm cubic meter, and existing installations even got up to 40 milligram per cubic meter. So also, it's from 2015, so I guess by now we should be at the 25 milligram per cubic meter level. If you look in the BAT conclusions, you can see the list of primary measures or abatement techniques, and also information when you can apply those levels and when there are exemptions. Next slide, please. Yeah, now we come to the examples for the water. Next. Still, we stay in the kraft pulping process, and we are looking a little bit into the water emissions, which mainly come from the bleaching processes. And yeah, of course, you have the organic substances expressed as chemical oxygen demand. You have the chlorinated organics like the AOX, also chloride, some nitrogen, some nutrients, suspended solids, and yeah, that's about it. Next slide, please. Yes, and it's a very water-intensive process, the pulping and also the paper production. So in order to reduce freshwater use and the generation of wastewater, BAT is to close the water system to the degree which is technically feasible, in line with the pulp and paper grade manufactured by using a combination of the techniques given below. And that's a lot about monitoring and optimization your processes so that you know where is the most consumption and where can you maybe recycle. Evaluate where you can recycle or even close the water loops. Then keep clean water apart from contaminated water, and use countercurrent flow. So use the clean water where you need the highest quality of water. And so for the wastewater flows, we have some examples here. Where you also see for the different processes of paper production, you have different wastewater flows. And that's just examples, and there are further developing. Next slide, please. So why do we think that water management is a very important parameter for the pulp and paper industry? Is because pulp and paper industry is a water-intensive sector. The water flow is probably the key indicator for efficient use and management of water, and also associated often to the emission load. In Europe, the maximum wastewater flow is regulated in almost all permits for pulp and paper mills. And that's probably maybe also the case in other countries across the world. And we usually measure emissions of pollutants in concentrations. And if you want to know which is the specific load that ends up in the environment, you have to know the corresponding wastewater flow. And that's why we really have to have a value of the wastewater flow. Next slide, please. And here you see the continuous optimization of processes in paper mills in Europe. And it started in the 90s with 15 cubic liter per kilogram of paper produced. And now we are at 8 liter per kg product. Next slide. Yes, again, one example. There are many more in the BREF document. Please go and have a look yourself. We are again in the kraft pulping mills, and one of the most important steps is the bleaching process. We have about 25 cubic meter per ton of pulp produced. And there are, if you close or partly close the bleaching plant, you can reduce the load of organic substances by 25 to 50%, and the wastewater flow to 12 cubic meter per ADT, dry ton. In Europe, chlorine gas bleaching is banned, and both modern elementary chlorine-free bleaching ECF process and totally chlorine-free bleaching TCF process is considered as best available technique. Next slide. Yeah, modern ECF bleaching. I know we don't have a lot of time, so it's really difficult now to present this so short. There are different kinds of elementary chlorine-free bleaching. You can optimize this process by using different bleaching stages, which also use other bleaching agents like oxygen or hot acid hydrolysis stage, ozone stage at medium or high consistency, or stage with atmospheric hydrogen peroxide. Or use hot chlorine dioxide stage. And if you use these different optimization stages, you can reduce the concentration of dioxides and furanes to undetectable levels. Also, we don't even control it in Europe anymore because we are very, very low. And also you can reduce the AOX formation and optimize the energy and water consumption of the overall process. So the agreed environmental performance level as a BAT level of a modern ECF bleaching is below 0.2 kilogram AOX per ton. And the most advanced plants using this process come even below 0.1 kilogram AOX per adult ton. Next slide, please. Yeah, here you see the BAT associated emission levels for the kraft pulp mills, and the ranges are quite wide still. I don't want to go much into the details. If you have unbleached process, you see the levels are lower. Yeah, COD you see when you are bleaching up to 20, when unbleached mills are only up to 8. Yeah, all the suspended solids, nitrogen, phosphorus, depends on the optimization of your wastewater treatment plant. You can achieve about similar levels. And of course, unbleached mills, you don't have AOX, and bleached mills, you have AOX. If you produce certain types of pulp that need more strength and stiffness, you might even have higher AOX levels. So you always have those comments on applicability on the BAT IELs. Next slide, please. Yeah, also, that was also covered by the OECD report, and it's also covered in the BREF document we want to elaborate for Gujarat on the processing of recycled fiber mills. And here you have different processes. With the inking means that you remove the printing inks from the fibers, and without the inking you don't do that. Without the inking is mainly packaging. With the inking is graphic or tissue paper. And also here, depending on the type of process you have different emission levels. If you have with the inking, you have, I think it's wrong, should be the other way, but as I think the levels are higher if you have the inking, and if you don't have the inking, the emission levels are lower. I think it's the wrong heading of the table here. I'm sorry, I can hand this after. Yeah, of course, there are also some mills that have a closed water circle, which don't produce any emissions or wastewater. But those mills also have different problems with corrosion and odor, and they have to be managed and optimized and monitored in a very, very good way. But it's possible for small mills. Next, and certain products. Next slide, please. Yeah, also this BAT process is a European process, and then in Germany it's the case that we compare the BAT conclusions with our national binding rules, and if a BAT conclusion is more demanding than the national requirements, we have to revise our national binding rules. If it's equal, it stays at the same. And if it's not included so far in the national requirements, we have to introduce it. So for Europe and also, for Europe and especially Germany is then part of Europe, we have to implement these BAT conclusions in our national binding rules. Next slide. Yeah, very important is monitoring and control of emission parameters. We have different systems of monitoring and control in also different in the different federal states of Germany. But we always have control by local competent authority. They do random checks without prior notification. They use specified analysis methods which are specified in the wastewater ordinance, and there are several rules for what happens if they don't apply. Yeah, so it's all kind of regulated what happens. Just a very short brief. You can read it after. Next slide, please. Yeah, BATs are revised. Also, the paper BREF is quite old now. It should be revised soon because the techniques are further elaborating. And it's a dynamic concept that requires regular evaluation and updating. Because also the installations have to be retrofitted, and we think it's very good that to have it to be binding and also to transfer it into our national binding rules as a clear guidance for the permitting authorities as well as the operators. And only in this way, it leads to a level playing field of environmental standards for industrial installations. And the operators also have the advantage that they know what they have to expect. And yeah, we really are fond of the system because you have this process and product specific conclusions and also this emission limit values. And you don't say every installation has to meet a certain value because it's more appropriate to look into the processes that are applied. Yeah, and we also think that independent control by authorities is still needed for the enforcement of environmental standards, but it also can be a complement or it can work in a very good system combined with a continuous self-monitoring of relevant parameters by the operators. Next slide. I think that was the last. I think that's just some links. Yeah, you can skip that. Next, please. I think you get the slides afterwards. You can find just the BREF documents. You can find information on the German Environment Agency and our regulation. Next. I'm done. Thank you very much for your attention, and I'm looking forward to your questions.
Thank you very much, Almut, for presenting the European BREF pulp and paper together with the OECD, referring to the OECD report, including the discussions and backgrounds of the BREF document. Now, I would like to move to the session 4. The discussion session on harmonization of BAT approaches across industries. I would like to invite all the speakers in the previous sessions, and together with Mr. Philgo Kang, senior researcher of the National Institute of Environmental Research of Korea, And then also I'd like to invite Mr. Marx Strauss from the European Apparel and Textile Confederation, Eurotex. In this session, we would like to have a broader discussion on harmonizing BAT approaches, although we have a limited time. So I'd like to hear speakers' views on comparing BREFs across countries and sectors. Particularly, the discussion points could be, for example, how different countries define and apply BAT for emission control in both sectors, and then differences in BAT AELs and factors influencing variations. Or it could be challenges in harmonizing emission limits across jurisdictions, or commonalities between the two sectors in the BAT used. And then it could be the OECD's role in streamlining and harmonizing BAT approaches. So first, I'd like to ask Damien to provide a few words on this agenda item.
Yes, many thanks. Well, actually, it's difficult to have a definite opinion that applies to all parameters, let's say. So maybe I will start with how the emission limit values are identified in the sectors, because here, for all BREFs, the definition of all best available technique conclusions, the process is the same. It's an information exchange involving stakeholders in both cases, whatever the sector. The group is similar, and the group agrees on key environmental issues for the sector. Based on the key environmental issues that are identified, they agree on a plant-specific questionnaire to collect data and information. And actually, the emission limits values that are associated to the use of the best available techniques for a given sector are the result of the assessment of the data collected and the information collected by the group itself. It's both industry, environmental NGOs, and the European member states that contribute to the information exchange, and at the end of the process, conclude on the BAT conclusions and the emission limits. So if the value differs from one sector to another, it is due to this process, actually. The result is specific for the sectors. Of course, for some general techniques that can apply whatever the sector, there are similarities. But sometimes it is difficult to agree on similar ranges across different sectors. So this is for the methodology. Saying that, and to conclude, it's always interesting to bring together all the stakeholders, we believe, because in the end, the objective, the common objective is to have a continuous improvement of the environment as a whole. And the way the best available techniques and emission limits values are identified sector by sector brings also flexibility, maybe helping the implementation then in the sectors. So maybe to open the discussions with that. Thank you.
Thank you very much, Damian, for presenting your points, important points to have the commonalities or differences between the sectors. Now I'd like to invite Mr. Shaw to provide a few words.
Yes, hello, my name is Markus Strauss from the Textile Association Germany, at the moment representing Euratex, the European apparel and textile industry. And we have heard a lot about the process of gaining information about the emissions and energy consumption, the water consumption of any kind of textile process or paper process. But I don't want to talk about problems. I'd like to talk about some recommendations, because if you look at textiles, most people always think of textiles as apparel, something like this. But if you think that the wings of a windmill or a wind power plant are also textile, that in a car, not only the seat, but the air and the fuel filter system is textile, that you have textiles in medical devices and in the environment, for example, by protecting streets and dams from erosion. I think in the process, these specialties have not taken into account, because there are a lot of interactions and there are a lot of connections between emissions and production that have not resulted that they have resulted in the discussion, but they didn't result in the ranges of emission factors, for example. And we recommend in the national discussion and in the discussion by taking these international laws, that the kind of textile, the fabric, the industry produces, and the local machine works, that these are taken into consideration. It makes a big difference if a factory produces geological textiles or medical textiles, and this has to be a very intense part of discussion between the authorities and the fabric producers. Thank you.
Thank you very much, Mark, for sharing your views from the industrial perspectives. Now I'd like to ask Phil to present a few words.
Okay. Actually, Korea has a different legal situation from the EU, such as the coexistence of the media law and VAT law in Korea. Also, VAT, AEL, as well as VAT is not obligatory. In other words, we have powerful VAT permission information systems and our one emission impact analysis model. So I think the different harmonization of each country on VAT policy is likely the next project theme, hopefully. And actually, maybe Naoko will know that my colleague prepared the presentation in this webinar. It is my fault, but my bottom line is I would like to show our recent updates on pulp and paper and textile dyeing BREFs this year. We will publish the second version of the BREF, but our activity 6 and activity 7, our sector is originated from first version BREF. So hopefully I will send this PowerPoint slide to Naoko and Barak, and if possible, you can distribute to our participant and discussion panels. And also my final announcement, we will open the international conference before the expert meeting on November. So I will send an invitation letter to ask to be a speaker each. Hope to see you in Korea. Yeah, that's all.
Thank you very much, Phil, for briefly introducing your views. And then thank you for sending the slides. We would like to circulate the slides afterwards. And then I will invite Ms. Almut Richard.
Yes, thank you. Okay. Yeah, I always find it very, very special and interesting to see all the different also different sectors, also different countries, and the different approaches, and how we all try to find a good way to also to balance environmental legislation with industrial production. And I think I want to emphasize a little bit on the TWGs and the unique point of this BAT approach in Europe, I think, and which makes it a role model, I think, for a lot of other environmental problems, is that you take on board all the information as a holder, yeah, like the operator, the machinery suppliers, the chemical providers, the boiler house, also manufacturers, but also NGOs, to have the public opinion, and then the national representatives and of the competent authorities. And then also you don't involve them in the end of the process, but also already when you're scoping the document, or when you identify the key environmental issues, and then you follow a very transparent way to elaborate this BAT conclusions in the end. And we have this documented in the guidance documents, which is revised now, and everybody has the opportunity to participate. And I think that's also the answer to Markus Strauss' question. It is very important that the industry is providing information as on the processes and the details also, and also the rationale, and not only saying it doesn't work like this and that, but it doesn't work because we do this and we need this product for this, and this is combined with these techniques, and those emissions are resulting. And I think we have to come back also on the European stage on a more technique focused discussion. I think we lost this a little bit. And I think that is a good way to find those compromises. And then also keep in mind that this world balance, like we have a lot of production in, like Mr. Jeter, I don't know, that you showed a lot of production is taking place in other parts of the world. So we have to be responsible for our products that we consume in the industrialized countries. And I think this BAT group, OECD group, brings together very well these different approaches. And I think it's a lot of learning experience also for us. And yeah, I think it's very beneficial. I don't know if this was an answer to your question, but yeah, you have to ask again. Thank you.
Thank you very much, Almut. Now I would like to ask Niraj, would you like to provide some comments? If not, I'd like to pass the floor to Barak, my colleague.
Thank you very much, Nako, and thank you everyone for your really essential comments and reviews of our work, and as well as your current works and where you see the industry could improve, and the challenges and opportunities possible. We did remark as to also include that we did remark across our reports that there were diversities in the BREFs based on the geographical location, the raw materials availability, as well as the processes that are used for the specific textiles production. So it was also noted that the geographical and the legal structures of the BREFs played a critical role in the BAT selected and the BAT associated emission levels. Further to feel good, we're very glad to hear that Korea is developing their second version of the paper and pulp BREF, which, as I mentioned earlier in our presentation, we do have an online platform where we publish all the BREF documents available globally in various sectors. So we will make sure to include that in our database, which is publicly available on our portal. And I'd like to also reiterate that the beauty of the OECD's work on BAT, we have an expert group, as I included in our presentation. This expert group not only consists of OECD member governments, but also welcomes expertise from non-OECD member governments, industry associations, NGOs, as well as academia. So if anybody is interested in participating in our work or would like to carry out further exchanges for our work or including our work, please do feel free to contact us. And I guess we can quickly go into the important probably question that anybody could have. Please do feel free to send your questions to us, and we will make sure to distribute them to the speakers of your interest. And I guess we can pass on quickly to the closing remarks. To reiterate, on 13th of June, we did have the first of our webinar series, which focused on thermal power plants and iron and steel. And today we wrapped up our webinar on textiles and paper and pulp. In the future, we will develop another and the final of the series, a webinar on cement and waste incineration sectors, which will be falling into mostly October of this year. And if you have any suggestions and any questions or any suggestions on future studies, feel free to send us an email. With that, I'd like to thank you for your attention, and please do feel free to reach out to us and click on these links for further information. Thank you very much.